Plane pi is represented by the equation given here in parametric form. We want to determine negative 2, 2, 3 cross 2, 1, 0, and note that those are the two directions that we know are in the plane when we're in parametric form. So we've got I, J, K, negative 2, 2, 3, 2, 1, 0. They have to go in that order because A cross B and B cross A are not the same thing. And just to explain, when we're in parametric form, we know that the point 315 is on the plane, and then these two things that are multiplied by lambda and mu would be two directions that are in the plane. So covering up I gives us 0, take away 3. Covering up J gives us 0, take away 6, but we change the sign on that middle one. And covering up K gives us negative 2, take 4, which is negative 6. And what this represents is a direction which is normal to these two vectors which are in the plane, and therefore is the normal to the plane. Show that the equation of the plane can be written in this form. Well, we know that r dot n is equal to a dot n, where a is a known point on the plane, which we're going to use this one for. So r dot negative 3, 6, negative 6 is equal to 3, 1, 5 dot negative 3, 6, negative 6. So r dot negative 3, 6, negative 6 is equal to negative 9, add 6, take 30. So that's negative 39, add 6, which is negative 33. So in Cartesian form, negative 3x plus 6y, take away 6z is negative 33. Divide through by negative 3 and we get x minus 2y plus 2z is equal to 11 as required. Consider the sphere with its centre at this point. Determine the Cartesian equation for S if plane pi is tangential to the sphere. So we've got a centre here at 3, 4, negative 1, and we have our plane. So if we take this line so that that's perpendicular, this line here would have equation r equals 3, 4, negative 1 plus lambda. Now, it's normal to the plane, this, so it's going to be, well, we could use negative 3, 6, negative 6, or here we could use 1, negative 2, 2. And we want where that intersects with the plane. So that gives us x is 3 plus lambda, y is 4 minus 2 lambda, and z is negative 1 plus 2 lambda. And our plane was x minus 2y plus 2z equals 11. So that's 3 plus lambda, take away twice 4 minus 2 lambda, plus twice negative 1 plus 2 lambda equals 11. So 3 plus lambda, take away 8, add 4 lambda, take away 2, add 4 lambda equals 11. So looking at the numbers here, I've got negative 10, add 3 is negative 7, take that to the other side is 18. And I've got 9 lambdas, gives me lambda equals 2. And therefore this point here is going to be when lambda is 2. So it is going to be 5, 0, and 3. So that enables us to work out the radius. which is going to be the square root of 5 to 3 is 2 squared, add 4 squared, and 3 to negative 1 is also 4 squared, which is the square root of 32 and 4, which is 36, which is 6. So that means the radius of our sphere is 6. So the modulus of r take away the centre of the circle is at 3, 4, negative 1 is equal to 6. Now we were asked for Cartesian equation, not the vector equation. So that would be x minus 3 squared plus y minus 4 squared plus z plus 1 squared equals the radius squared.